Hi, welcome to the second video in Georgia Tech CS 1331's debugging series. My name is Lauren, and today we're going to be going over runtime exceptions. So we can see here that we're looking at the same calculator class as in the first video. So in case you didn't watch the first video, or just as a refresher, let's go back over the intention of our program. So we wanted to ask the user for a mathematical expression. We will then evaluate the expression and print out what that expression evaluates to. So let's go ahead and compile our program. And to do that, I'm going to type in javac calculator.java. And it compiles, which is a good sign, considering we fixed our compile errors in the first video. So now we're going to try running our program. And to do that, I'm going to type in Java calculator. It's important to note that when we run programs in Java, it's not necessary to add the .java after the class name. So it asks us to enter a math calculation on a single line. So I'm going to type in 1 plus 2 and hit enter. Oh no, so we can see that we've run into an exception. Exceptions in Java mean that we have some sort of error or a mistake in our program, which is stopping it from running. We can see here that in this instance, we have a java.lang.array index out of bounds exceptions. Array index out of bounds exceptions occur when we try accessing an index which does not exist in the array that we've created. So we can see here that we've tried to access index 1, an array of only length 1. Remember that in Java, arrays start indexing at 0, which means that an array of length 1 can only have index 0. Beneath that is what we call a stack trace. We'll be explaining more what stack traces are in our next video, but for the time being, we're going to look at the top line, which tells us where the issue is occurring. In this case, it's calculator.java, which is the program we're currently looking at, in line 13. So let's go ahead and look at line 13. So we can see here that that is our switch expression. And we're trying to access index 1 in our split expression array. So because we're accessing index 1 here, and our exception told us that we had an issue with accessing index 1, that then implies that split expression is only of length 1. So let's see where we're actually assigning split expression. That happens to be the line above our error. So we can see that we're assigning expression.split to split expression. In Java, the split method takes in a parameter, and that parameter is used as a delimiter. A delimiter in this case means that we're taking everything before a space and putting it into a new index in our array. So because this is where we're actually creating our split expression array, it means that our split expression is only of length 1, which therefore means that expression only hits one space. So let's try printing out our expression, system.out.println expression. And the reason that I'm printing out expression is because I want to be able to see what we're actually splitting to put into our split expression array. The reason that I'm putting it above the line where the error is occurring on is because exceptions in Java stops the current method from being run. That would mean that once I hit line 14 and an exception is thrown, nothing beneath it would continue to run. So it's important that we put our print statement above that line. So let's go ahead and save our code and recompile. It's important that we recompile every time we make a change in our code. So it compiled, so let's now try running it. Java calculator. And again, I'm going to enter 1 plus 2. This 1 here, which was printed beneath the user input, is what we've printed out as our expression. So we can see here that expression was only the number 1, and not 1 plus 2, like we had expected. Let's go ahead and look where we're assigning expression, which in this case is line 7. string expression equals scan.next. So this line is intending to take in all of the user input. However, it's only taking in the number 1. Chances are that means that we're using the .next method incorrectly, or it means that we have a misunderstanding with the next method. Java actually has a really handy tool called the Java API, which has a list of all the methods and classes in the Java standard library. So let's go check that out and see what the scanner.next method actually does. Okay, and so to find our Java API, we're going to go to our search bar and type in Java 11 API scanner. And we're going to look for the link that says docs.oracle.com. And here's our Java API for scanner. So we're going to scroll down and look for where the scanner.next method is described. So we can see here that this is our method summary. And we're going to look for the next method. And here's our next method. Just as a tip, when reading the Java API, on the left is a return type. This middle section right here is the name of the method. And on the far right describes what the method does. So in this case, the next method finds and returns the next complete token from the scanner. So by default, Java uses spaces as delimiters. So in other words, what this means is that every time it sees a space, what's before it is going to be used in our next method. So that explains why when we used scan.next, it was only reading in 1, because after 1, we had written a space afterwards. So let's look and see if we can find some sort of method that will take in our entire line of input. So I know that we're going to be looking for our next line method. And just to be sure that we're looking at the correct method, we can look at the description of it, where it says, advances the scanner past the current line and returns the input that was skipped. In other words, it takes in the entire line of input. So let's go ahead and go back to our code and use .nextLine instead of .next. So let's look back at our code where we've used .next. So again, the next method was seeing the space after the 1, which determined that it would stop reading in more input, which is why we were only getting in 1. So let's change our next method to next line. And I'm going to comment out our debug print statement in case we have to come back to it later. So let's save our code and recompile. Okay, and now that we've compiled, let's go ahead and try running our program again. Java calculator. And we're going to enter in 1 plus 2, and it prints out 3.0. Okay, so now that we've seen that that works, let's try and run it again, and this time I'm going to put in an odd character instead of a normal mathematical operation. So why am I doing this? I'm doing this because it's important for our code to be able to handle any user input. It's near impossible to ensure that our users are going to use our code correctly, which means that our code should be able to handle incorrect output or output that we weren't expecting. I'm not going to go through all 3 parts of it not being correct, but in this case, I'm just going to try to do an incorrect arithmetic operation. So let's try putting in 1, question mark, 2, and see what happens. So we can see that our code broke. In this case, we have a java.lang.nullPointer exception. A null pointer exception occurs when we try an operation on a null object. A lot of times this happens when we try calling methods on null, but it is not always the case. So let's take a look where the null pointer exception is happening. We can see here that it's happening in our calculator class on line 8. So let's go ahead and check out line 8. So we have double answer equals evaluate expression, expression. So let's kind of walk through what's actually going on here. We're trying to set evaluate expression and assign it to answer. Evaluate expression returns a double, which means that we're auto unboxing. So let's see, when we put in a question mark, as we've done, our code is going to look and see if split expression 1, which in this case is our question mark, and it's going to try to match it to one of our arithmetic operations. So it's not the plus, it's not going to go into this case, it's not going into the multiplication case, it won't be the division, it won't be the exponent, and it'll go into the default. So when it goes into the default, it means that it hasn't matched any of the other cases. So we can see here that we're returning null, which is where our issue is occurring. We're trying to assign our null object to our double answer. So let's see. We know that when we have not matched plus, minus, multiplication, division, or exponent, that means that our user has somehow inserted incorrect input. So a way that we could solve this issue, instead of using null, is using double dot NaN, which essentially means not a number. This makes sense here because if they're putting in 1 question mark 2, then there's no arithmetic that we need to be solving. It's not a number. So let's try saving and recompiling our code. javac calculator.java. And let's go ahead and run our code. And again, I'm going to type in a question mark instead of an actual arithmetic operation. And we can see here that it prints out NaN, or not a number. Okay, great. So now our code is working and even handles certain cases when the user doesn't necessarily type in what we expect them to. So let's see if we can add something else to our code. Maybe let's print out, "Thanks for using the calculator." So I'm going to create a string variable called thanks. And I'm going to assign it, "Thank you for using our calculator." So again, I'm going to use system.out.printf. I'm first going to add a new line to separate our answer from the next statement. And I'm going to use the flag to print out our string variable thanks. So let's go ahead, save our code, and try compiling. javac calculator.java. Great! So it compiles. So now let's try running our newly edited file. So I'm going to say 1 plus 2 again. Oh no, so you can see here that we've entered another stack trace. If you go to video 3, we'll go more into depth about how to solve stack traces and what stack traces actually are. Thanks again for watching video 2.